So problem number 2 says a musician tightens a string on a guitar. The speed of the wave V traveling along the string depends on tension T in the string and then linear mass density nu of the string. And they are telling us that the linear mass density nu of the string is mass per unit length. So they have given us a hint of determining this nu. So the task is to use dimension analysis to find the relationship between wave speed V, the tension T, and linear mass density nu. So here we are told that it is speed V that depends on tension T and linear mass density nu. So we are going to find the solution to this problem. So the solution says that speed V depends on nu, that is mass per unit length, okay, and tension capital T. So that means we can say that V is directly proportional to nu, okay, which nu is to power a particular value A, and tension, okay, tension T to power a particular constant B. So meaning if we create equal signs, then V is going to equal to a dimensionless constant K times nu power A times T power B. So therefore, we need to look at the dimensions of V, okay, which must equal to dimensions of velocity. And we already know that this is distance out of time. So we shall have dimensions of displacement out of dimensions of time. And this is equivalent to dimensions of displacement is L, and the dimension of time is T. So therefore, the dimensions of velocity equal to the dimensions of V will equal to L T to power negative 1. So what does that mean? We also look at nu. What are the dimensions of nu? We have already been told that nu is equal to mass per unit length. So per unit length means we're talking about mass divided by length. So that means I will have dimensions of mass out of dimensions of length, which will be capital M divided by capital L. And this is going to be M times L power negative 1. Then what about dimensions of tension is equal to dimensions of T, okay, that we're talking about here. And this is the same as dimensions of force, because tension is the same as force. But now what about force? What is force? Okay, we know that dimensions of force will equal to dimensions of mass times dimensions of acceleration. Okay, so what does that mean? I'll have capital M, okay, times acceleration, which is L T to power negative 2, because this is the same as velocity L T to power negative 1 divided by T, which becomes L T to power negative 2. Therefore, the dimensions of tension must equal to capital M times L to power negative 2. So if I call this 1, I call this 2, I call this 3. So I'll just come and substitute in this equation, which was star. So meaning what I'm going to do, I'm going to substitute 1, 2, and 3 in equation star. So therefore the dimensions of velocity or speed must equal to K times dimensions of what? The dimensions of nu power A times dimensions of T power B. But what are the dimensions of velocity? We already know that this is the same as LT to power negative 1, which is equal to K times the dimensions of nu, which is mass per unit length, so which is M, L power negative 1, and this is to power A, times the dimensions of force, tension, okay? Tension is force, so therefore, we are going to be looking for, we are going to just substitute in this M, L T to power negative 2, power b. Then I just now open the brackets. I'll have a to the power 1 and t to the power negative 1 equivalent to k times m to the power a times a to the power negative a times m to the power b, if I open brackets here, times a to the power b times t to the power negative 2b. I again correctly write terms together. So I'll have a to the power negative 1, t to the power negative, a to the power 1, t to the power negative 1 equivalent to k times m. So the m's, I bring them together. So this is going to be a plus b times l. L is going to be b minus a times t power negative 2b. Remember this side, we have m power 0. So we equate the powers on right hand side and left hand side. So meaning here, the powers of m must equal each other on both sides. So a plus b must equal to 0. Next is that this is negative a plus b. Let me sort it here. This is negative a plus b. And this is equal to L is 1. Then t, we know that negative 1 is equal to negative 2b. So from the third equation, it says that therefore negative 2b is equal to negative 1 divided by negative 2, and therefore b is equal to a half. This negative and that negative will go. So b is equal to a half. Next is to calculate for a. So here, from here, I can say that if I move this, okay, let me say negative a will equal to 1 minus b. So meaning that negative a will equal to 1 minus a half. So meaning that my negative a will equal to 1 minus a half is a half. So I divide both sides by negative, and therefore you will see that a is equal to negative a half. Therefore, hence, speed v will equal to k times nu, okay, which nu is to power a. We say the nu is to power a. So, but a is negative a half. And then t power a half, because t is to power b. Therefore, v will be k, t out of nu, everything power a half, and this will be k times square root of t out of nu. And therefore, speed v will equal to v equivalent to k times square root of t out of nu. As simple as that.